Foundations of Amateur Radio. Recently, I made a commitment to building a crystal radio. That started a fevered discussion with several people who provided many helpful suggestions. This is the first time I'm building a crystal radio, and to make things interesting, I'm selecting my own components and circuit diagram. What could possibly go wrong? Crystal radios have been around for a while. Around 1894, Indian physicist Jagadish Chandra Bose was the first to use a crystal as a radio wave detector, using galena detectors to receive microwaves. He patented this in 1901. The advice I was given sometimes feels like it harks back to 1894, with suggestions of using cat's whiskers, razor blades, and any number of other techniques that create the various components to make a so-called simple crystal radio. At the other end of the scale, there were suggestions to go to the local electronics store and buy a kit. The first suggestions, rebuilding historic radios from parts made of unobtainium, would mean many hours of yak shaving just to get to the point of getting the components, rather than actually building the radio. I realise that part of the experience is the journey, and I'm sure that if my current project gets me hooked, I'll look into it. But I really don't want to become that amateur who has a collection of homebrew crystal radios across the ages. Besides, I'm having a look at using my crystal radio as a front end to my software, so I want to keep sight of the radio part of what I'm doing, rather than the building part. Before you get all hot and bothered, remember amateur radio is a hobby that means different things to different people. And for me, I'm currently playing with software, and I'm attempting to learn about the electronics principles that form the basis of our hobby. As I said, the other end of the scale was to get a kit and build that. It has its appeal, but there is little in the way of learning, and the construction part of things is pretty much putting together a kit, which is something I first did when I constructed an LC meter kit a while ago, so that too doesn't really appeal to me. Now comes the bit where I tell you what I've done to date. On the physical side of things, nothing. On the thinking and learning and planning side, lots. Here's where I'm at. My current understanding of a crystal radio is that you need to detect the AM waveform from an RF frequency and pipe that into something that makes noise. Traditionally, this is done with a crystal earpiece, but I saw someone use powered computer speakers with a built-in amplifier, so I'm going to start with that as my first noisemaker. I should also mention that the crystal earpiece was a source of confusion. I thought that the crystal in crystal radio was referring to that one. It's not. So, back to where I'm at. What do I need? To start off, I cannot just connect an antenna to a speaker, since it will attempt to make sound for every known frequency. Well, at least the ones that the antenna can handle that fit within the response envelope of the speaker and its amplifier. If you want to know what that sounds like, put your finger on the input plug to some powered speakers. Don't turn up the volume too loud. You'll regret it. So step 1 is to make a way to only let specific frequencies through. I've previously discussed this. You might know it as a bandpass filter. You can make one using a capacitor and an inductor. If you make the capacitor variable, you can change what frequency passes. This is helpful because you don't want to be decoding more than one radio station at a time. There are plenty of designs for crystal radios that offer hand-wound inductors and homebrew capacitors, but I'm not doing this to learn how to build those. I'm doing this because I want to learn how it works. I want to use readily available components from my local electronics store. So I started with building a spreadsheet that shows what the resonant frequency is for a combination of inductors and variable capacitors. Today I learned that I also need to pay attention to how wide this is, so I'll be revisiting this. There are only two more components in my radio, a diode and another capacitor. The diode cuts off half of the information, since, if you recall, AM uses two sidebands that are identical. At that point, you have a signal that contains both the carrier and the audio signal. You need one last step. Filter out the high-frequency carrier. I've talked about that too. This is a low-pass filter. You can do this with a capacitor. So now we have the bare bones of a crystal radio made from 4 components: an inductor, a variable capacitor, a diode, and another capacitor. My next challenge is to figure out what values they have so it will allow me to listen to my local AM radio station and do it using components off the shelf from my electronics store. One thing I can tell you is that this is precisely why I signed up for this project. I don't want a ready-made radio from a kit, and I don't want to have to learn how to chop down a tree in order to make a pencil. I'll keep you posted. If you have additional reading material you'd like to suggest, feel free to get in touch. I'm Onno, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.